Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. I'm gonna go straight to what we have for today. We've talked about how to integrate sine, how to integrate cosine, how to integrate sec squared, and rules for them. But there are other integral derivatives. Because of time, I can't go through all of them. So what I'm going to do is that I'm going to make a list of them, okay? So just a list of them that you can know. Usually in most exams, these integral derivatives are given in the formula sheet. In some of them, they are not. So I usually advise, based on the university or the college you are, try as much as possible to get familiar with your formula sheet. And if not, if you don't have a formula sheet, you then have to make sure you memorize this as well. All right, so before I proceed, don't forget to like, share, and subscribe. And if you have any question, please do not hesitate to contact me. Send me an email or drop it in the comment section, and I'm going to get back to you on it. Okay, so I'm going to list all the integral derivatives. Okay, so before we go to this video, make sure you understand the rule A, B, C, what we talked about, the cosine, the sine, as well as the sec squared. So try as much as possible to get conversant with that. So the first one I'm going to talk about is that when you're integrating sec x tan x, okay, in respect to dx, okay, in respect to dx, what you're going to get is going to get sec x plus c. So when you're integrating sec x tan x in respect to x, it will give you sec x plus c. Number two, when you're integrating cosec x, all right, cosec x cos x. So you're integrating cosec x cos x in respect to dx. What you will get will be minus cosec x plus c. Okay. Then the third one, when you're integrating cosec squared, okay, integrating cosec squared x in respect to dx, okay, what is going to give you is going to be minus cot x plus c, all right? So when you're integrating cosec squared x in respect to x, you're going to give you minus cot x plus c. Number four, now when you're integrating tan x, okay, in respect to dx, it's going to give us the ln of sec x plus c, okay? It's going to give you the ln of sec x plus c. So all this has different proofs to get them, but I don't want to go straight into this so that because of time, so I want to go into the other rules of integration. All right, so you can go to the textbook and try that. So they have different proofs of this, so you can practice as well. So number five, so if for instance you were told to integrate sec x, okay, in respect to x, all right, it is going to give you ln of sec x plus tan x plus c, all right? So if you're integrating sec x, it's going to give you the ln of sec x plus tan x plus c. Then the next one, number six, okay? Number six, if you're integrating 1 divided by a squared plus x squared, okay? In respect to x, that will give you 1 over a, the tan inverse of x over a plus what? Plus c, okay? Number seven, if for instance you are told, but this time, instead of it to be just the 1 divided by a squared plus x squared, but this time you have a square root of a squared minus x squared in respect to dx, okay? You have a square root, so it's going to give you the sine inverse of what? X divided by a plus c, okay? Number eight, if for instance we're told, but we're dividing, but this time it's a linear function at the bottom, so ax plus b, all right, in respect to x, okay? So it's going to give you 1 over a the ln of the absolute value of ax plus b plus c. Okay. Then number 9, if you're told to integrate cosec x cot x in respect to what? Dx is going to give you minus cosec x plus c. So exactly, this is exactly the same thing as number 2. Okay, it's exactly the same thing as number 2. So what I can do, yeah, I can just leave it there, but just what I did, I just repeated it twice, all right? Then the next one, number 10, if you have to integrate cot x okay, integrate cot x and in respect to x, okay, in respect to x, so it's going to give us minus ln, okay, of cosec x plus c, all right? Then number 11, if we're integrating 1 divided by 1 plus x squared, okay, will give you the tan inverse, will give us the tan inverse of x plus c. And number 12, if we integrate, but this time is 1 divided by square root of 1 minus x squared, is going to give us the sine inverse of x plus c. All right? So these are the other tricks. There are many more. If you go to the textbook, there are so many that you can also go and you can add to the list. But these are just some of them that I just brought out so that you can use and you can practice as well. So you can have, if you're integrating sec tan x, cosec cot x, cosec squared x, or you're integrating tan x, sec x, or any different form of these functions here, all right? So you can now go back and practice, all right? Practice with it. So that'll be that for trigonometry functions. I'm going to go to the next rule now on how to integrate when you're multiplying with a constant, okay? And I'm going to go straight out to the rule 7, all right? So I've talked about rule 6. I've tried to break it down into integrating cosine, sine, sec squared, and other integral derivatives, all right? So I'm going to go straight to the next rule, which is rule 7 in the next video. So try as much as possible to make sure you've subscribed and you click the notification bell so that when I post the next video on how to integrate when you're multiplying with a constant, you'll be the first person to know. So I'm going to see you in the next video, and I'll see you soon.